Is it on?
Yes.
There we go. Okay, so Haskell is a really nice language. And one of the nice things it provides is this indentation-sensitive syntax. Well, one day I'm going out and I'm like, well, why don't I actually figure out what that indentation syntax actually does? Well, I looked in the Haskell report and I met with a wall of text. Now, this text isn't too bad, but there's something weird happening here, that there's extra tokens that need to be inserted in various places to mark the indentation. Okay, not too bad. Then the Haskell report says apply this function. Well, I don't know about you, but that's going to take me a while to figure out what it means. And I'm not going to spend that time because it would take all of my time. But there's something really weird happening here. What this function does, this function runs before parsing, but what this function does depends on what the result of parsing is. That's bad. That's a cycle. Well, why don't we, well, the GHC has some really smart people implement it. Why don't we look at how they do it? They use magic. There's this complex protocol going on between the lexer and the parser, and they're interleaving their executions. And, Okay, well, let's. Fortunately, yesterday, if you were here, Erdweg has done some work in this area, and having a grammatical framework for specifying what indentation-sensitive parsing is. Now, he bases his work on a GLR parser. So intuitively, you can think of it as do the complete parse, as if you didn't know what indentation was, and then filter out the parsers that violate the indentation rule. Now, he interleaves some of the filtering with the parsing itself, so it's not like you have to generate the entire thing. So I also, before I found out about his research, I have also been looking into this problem. But I've been looking at it from a different perspective, which is that I wanted to be able to generate an LR parser directly rather than a GLR parser. I didn't want to do any non-determinism. I wanted to be able to generate LL parsers and do parsing much more directly. So this is the system I've come up with. On the top, we have code from ICFP, actually, which was indentation-sensitive parsing as well. Basically, think of it as Haskell, except things in parentheses don't have to obey the indentation rules. It's sort of like curly braces around do syntax. Down below, we have the sort of parse tree that we want to generate. Now, every terminal, we annotate with the column that terminal occurs at. And every non-terminal, we annotate with sort of the moral indentation at which it occurs. So the expression as a whole occurs at indentation 1, the first column, because we use 0 for special purposes. The right-hand side of x equals occurs at column 6. This expression here, x plus z, that's all the way over at column 0, which is, I'm going to skip explaining why 0 and 1 are different. Ask me afterwards if you want to know. Then what we do, okay, so this is what we want to produce. How do we specify what trees are valid? So if we start from the grammar for the syntax without indentation, all we have to do is add annotations to every non-terminal on the right-hand side. These indentations say what the relationship between a node and its parent should be. So for example, the root expression and the child expression must obey the greater or equal to. And once we get inside the parentheses, the star means I don't care. They can have any relationship. Does it work? So I looked at a number of indentation-sensitive languages, including Scheme. It actually has a mode that's not commonly used. ICFP, Miranda, Gopher, Orwell, Curry, Habit, Occam, Python, and of course the one we care about, Haskell. All of these work in this system. These two, I think they should work, but their rules are so complicated, I don't know what their rules actually mean. If any experts on these are in the room, I'd love to hear from you. The status is that there's a lot of math to get from this grammatical description that I just gave to you
to how do I generate an LR parser for this. It's possible, but there's a lot of math going into that. And I have implemented that LR parser in a very hacked up version of Happy. And I took the parser from Haskell source, which is using the GHC trick of the protocol going back and forth, and translated it to using my system, and it verified that it parses everything in base the GHC source or Haskell source parsed before. So the system seems to work there. This work is under review at Popple. And the last thing I want to bring up is a question to the community. There's some weird things that we parse that don't look like they should parse. This code is valid, obviously. But is this code, show of hands, is this parsable code? Is this not parsable code? It actually is. Because only the first token on a line is the one where the indentation matters. What about this one? Should this parse? Actually it does, because tokens after do parse. Sorry, this one does not, this one does not parse, because tokens after do matter. This one does parse. Thank you.